Hi there, everyone. We're back with the next four examples that are using the empirical rule. Okay, and so just to remind you, we've got two pieces of information on the axes here. One is the standard deviations, okay, and below that are the scores for the exam that correspond to these standard deviations. So remember, we were told that the mean is 83, so that it lives at standard deviation 0. And to obtain all the scores that are on the right side, you add the standard deviation each time, which was 2.5. And on the left side, you subtract it, okay? All right, in this case, we're looking to estimate the percentage of students who have scores that are more than 85.5. Okay, and so once again, I like to mark these with these little boundaries here, and then I like to shade in the area so I know what we're talking about. And so we want everything that is to the right, and the reason I know that is because it's scores that are more than 85.5 or higher, okay? Now this occurs, and actually this is ongoing there. And what you should notice is that this occurs at one standard deviation, right? Okay, now what you should realize is that this also would have a pair or a buddy area on the left side, right? Since this is symmetrical, okay? And let me just mark this part because that's the one I'm interested in. But we would also have this shaded in as well, right? Now the reason that's helpful is because this particular region that doesn't have any shading at all in the middle there is something we got to remove. Okay, if only we knew what that area was. Well, the answer is we do know what it is, right? It's 68%. We know that 68% is here. Now, that's not the answer, okay? So what do we do now? Well, what we know is that the area under this entire curve has to be 100%, right? And so what we're going to do is we're going to take 100 and we're going to subtract out that 68%. And what that's going to give us is 32. Okay, now why is that important? Well, what does the 32% tell us? Well, what it tells me is that the area in both of the parts that I have shaded is 32%. And listen to how I said that, in both parts, right, on the right and the left. But I'm not worried about the left side. Okay, so what we have to do then is divide this by 2, since the areas are symmetrical. And what that gives me is 16%, which is this area. So this is 16, and this is 16. And so if you actually add up all three of these, you should get 100%. Now, I should have prefaced this by saying there's more than one way to look at these, okay, to get an answer. And so if you follow this way, that's great. But if you think about it in a different context or a different way, that's fine too. Okay, so this is how we use some of the empirical rule to help us. So let's take a look at the next example. It says to use the empirical rule, we want to estimate the percentage of students who have scores that are more than 88. Okay, so that would be in this region here. We want all of this shaded in. Well, this is going to be worked exactly like we did the last problem, okay? The only thing is we are not, repeat not, going to be using 68% because these are occurring at 2 standard deviations, right? And so 2 standard deviations we know, if I get the pen to work here, we go, should be 95%. And so if we take 100 minus the 95%, that's going to be 5%. Okay, now what that tells me is that in both tails the area is 5%. So what I'm going to do is I'm going to divide that by 2, and we're going to get 2.5. So that means 2.5 and 2.5. Okay, so this is my answer, 2.5%. Now, here's another question. Let us suppose that we replaced more with less. How would we handle this one? Well, if we want the scores, okay, that are less than, or the percentage of scores, students who got scored less than 88%, then the area we're talking about is all of this, right? All of this would be shaded in. So the question is, how do we handle that? Okay, well, we know the middle 2 standard deviations is the 95%, right? And what I have to add is this extra piece here, which is the 2.5. And so this would be 97.5% as an answer. So another little variation there. Okay, the next problem says using the empirical rule, we want to estimate the percentage of students who have scores that are less than 75.5%. Okay, so less than 75.5%. So that's going to be, good grief, a very small area, right? Everything that's to the left here. Okay. Well, and again, let me mark this so we know that's the area we're worried about. We know that that has to have a buddy, right? Another partner area on the right side. Okay, so what you'll notice here is that these occur at the 3 standard deviation mark, right? Well, we know that that has to be 99.7. So all of this white space in the middle is 99.7. So what we're going to do is we're going to take 100 and we're going to subtract 99.7 and we're going to get 0.3. Now the problem with 0.3 is that's the area in both of these little tails, right? And so what I have to do is I have to divide that by 2 to get 0.15, and so that is our answer. So this will be 0.15%. Okay, and the final example here, we want to use empirical rule, and we want to estimate the percentage of students who have scores, let's see, between 75.5, okay, and 78. Interesting, so we are talking about this little piece. Okay, so how do we handle this one? Well, like I said before, that also means that we've got a mirrored image piece over here as well, right? 2 of them. And again, this is the one that I'm interested in, all right? So how do we handle this? Well, what you have to remember is that there's nothing beyond the -3 and 3, right? I don't have any area out here that I'm interested in or area out here that I'm interested in, okay? So we have to remember that it stops at 3 standard deviations. Okay, now 3 standard deviations out on either side we know is 99.7, right? Okay, and I know that at 2 standard deviations that's 95. Now why do we care about this? Well, do you see this big white space here? That I have to remove, okay? And what am I removing it from? Well, I'm removing it from the 99.7, okay? Because between -3 and 3 standard deviations, okay, is 99.7. And what I want to do is I want to take out all of this, okay, because then that leaves me with these 2 pieces here, right? 1 piece, 2 pieces, okay, and we'll deal with that. So somewhat similar to what we dealt with before in the other problems, and I think we subtracted from 100, right? In this case, we're not going beyond 100. We're stopping at 3 standard deviations. So we subtract here, okay? So we take 99.7 and we minus 95, and that gives us 4.7. So that means there's 4.7 in each of the 2 tails. So I take the 4.7 and divide by 2, because we're only interested in one of them, and we get 2.35%. And so this percentage is 2.35%. And actually this one is too, by symmetry. Okay, but the one we're looking for here is between the 75.5 and the 78. So I hope this provides a little bit more clarity on using the empirical rule and adding and subtracting our areas and doing some manipulations. Okay, there's again other ways in which you could have approached some of these problems and considered the areas in question.